Let's Science is brought to you by the StarQuest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give.
3, 2, 1.
We live in a universe of scientific wonders.
Every day, scientists are inching towards breakthroughs which can change our lives.
We're playing our small part in sharing these wonders with you.
That's why today is a fine day for science.
So let's science.
All right, so if ever I needed someone to Taze pray for me, this would be it. All right. Yeah,
Here we
so
go.
Lino, I'm not going to do a tally of our topics because as you and I, when Caroline hasn't been able to do science, we've had some very interesting ones. Yeah, so this one doesn't involve robots, it doesn't involve mushrooms, it doesn't involve concrete, all right? But it does involve dinosaurs, so let's move on to it. Yeah.
We'll try this out.
Let's over this.
Woo. Okay.
So I'm going to do my best to wade through this one. So the article that I'm using is from Science News, and it's titled, New Computer Analysis Hints Volcanism Killed the Dinosaurs, Not an Asteroid. Interesting topic because what if we've always been told it was an asteroid impact,
It's
right?
an asteroid. Or asteroid or asteroids? No,
Asteroid. It was a massive impact, yeah.
Wow. Okay.
Yeah. So the Mexican impact site in, I hope I get this right, Chicxulub, the Chicxulub crater is this massive crater that shows, which is an impact crater from an asteroid colliding with the Earth many million years ago and wiping out the dinosaurs. Now, this article challenges that. Doesn't mean that it's correct. I need to point this out. In fact, there are some challenges to the assumptions made at the end, which I'll go through as well. But this is interesting because they used a computer analysis. They plugged some variables into a computer, and then the computer came up with what's the most probable outcome for what killed the dinosaurs. So I'll talk about what the computer says happened and how that is being challenged by different scientists. If anything, it doesn't really, I don't know, does it change our understanding of how dinosaurs were wiped out? Maybe not, but it's interesting. I'll just say that. In terms of discussion and looking at all the variables, this is an interesting one. So basically, here's what happens. For decades, scientists have vigorously debated whether an asteroid strike or massive volcanic eruptions ended the reign of dinosaurs 66 million years ago. Roughly 3/4 of all life on Earth, including all non-bird dinosaurs, were extinct at that time, putting a dramatic end to the Cretaceous period. So researchers have devised a new way to identify the true dino killer. Let computers take a crack at it. So they're basically asking ChatGPT. No, it's
I was going to say, asking AI.
Yeah. It's a lot more advanced than that. Yeah.
Oh, no.
Yeah. So after their computational efforts, it says here, the outcome from the computer was that the massive bursts of gas produced by the Deccan Traps eruption was solely responsible for causing the extinction event. I needed to look up what the Deccan Traps were because I had no idea, but they are an area of India that were basically evidence of massive, and we're talking about huge volcano flows, right? And there's actually a photo in the article. If you've got the article there and you scroll down, you'll see this evidence of these massive, it was an area of massive volcanic activity. Not anymore. Now it's dormant or whatever. There's no volcano there now.
That is huge.
I think, yeah.
That area is huge. It's like
it's a massive
river.
area.
Oh,
yeah.
Well, lava coming through. Oh my goodness.
Yeah. So if you were there, it'd be amazing to see. You'd be dead, but it'd be amazing to see. So the eruptions from the Deccan Traps lasted roughly 1 million years and spewed massive amounts of gas-ridden lava across what's now Western India. So the computer believes, the computer is based on the evidence it's been given anyway, it says it's the gases from this lava that that wiped out the dinosaurs and any non-bird like species. Rather than come at it from the perspective of let's blame the volcanoes and explain why, or let's blame asteroids and explain why, the goal was to have as little human input or bias in the process as possible. And this is from Dartmouth computational geologist Alexander Cox. So the idea was, if we just plug the variables into a computer, what would a computer say? So the idea was to work backwards using evidence from the scene of the crime. Scientists do have a smoking gun. They have cores drilled into deep ocean sediments, which contain geologic data pointing to deadly bursts of gas to the atmosphere, particularly planet-warming carbon dioxide and ocean acidifying sulfur dioxide. He says, but such gases could have come from the asteroid strike as it incinerated rocks on the planet's surface, Cox says, or from the Deccan Trap's eruption. So previous efforts to understand the source of the gases have focused on timing, examining pulses of lava placement during the Deccan Trap's eruptions. And there's a link to that in the article if you want to investigate that further. But Cox says we only have best guesses about how much initial gas was in the lava. Estimated carbon dioxide concentrations in the lava, for example, vary by an order of magnitude, he says. So that's why we approach this from a gas emissions perspective rather than a lava flow perspective. The researchers, they used a statistical model called a Markov chain Monte Carlo approach, to which I say, well done. I have no idea what that is. So that part, maybe Caroline can do some more research into. But that's what they used. And for any scientists out there, you can decide if that's good or not. But that approach systematically considers the probability of different scenarios of gas emissions from different sources, converging towards possible solutions as the result of simulations move closer and closer to geologic observations. Yes, I read that word for word because I have no idea what it means. Anyway, no, but basically, look, it's the probability of all these different scenarios coming together, did it, and what outcomes can we get from that? So what made their approach powerful is that they harnessed 128 different processors, ORS, to run scenarios in parallel. So they've got all these powerful computers all running together. The processors then compared how they're doing at the end of every model run, like classmates comparing answers. Or in Catholic talk, they had a computer synod. There you go. Yeah. Although there was no praying. The computers didn't pray. But anyway, they didn't rely on the Holy Spirit for the outcome in this case. But that parallel computing meant that computations would otherwise that would have taken a year took only a few days. So again, this was a very powerful process. Yeah.
That's a real
So lots of data that they had to work with. So the observations that were used for the computers to process were data collected from 3 cores drilled. So this is core samples they drill out of the ground, which are many millions of years old. So these are deep sea sediments that spanned 67 million to 65 years ago.
Wow.
Yeah.
Wow.
So just a little bit ago. Yeah. And in these sediments, foraminifera, ocean-dwelling microorganisms whose carbonate shells contain different isotopes or forms of carbon and oxygen. So within the shell of these fossils and sediments is carbon and different isotopes of carbon. So very old, and that can be used as part of the measurement. So the shell's chemical makeup records the ocean chemistry at the time of their formation. So that can be used as a proxy to infer past global temperatures, as well as how many creatures were thriving in the oceans and how much carbon was moving between the atmosphere, ocean, and land. And remember that the theory that the computers came up with is that it's the carbon and other gases from the lava that wiped everything out.
Yeah, it would have.
Yeah, so these proxies can be used to measure how much carbon, how much life there was at that particular time. The simulations determines that the amount of gas spewed into the atmosphere from the volcanism alone was enough to account for the changes in temperature and carbon cycling determined from the foraminifera data in the drill cores. So the computers decided, yep, the gases did it, right? As for the asteroid strike, which formed the massive Chicxulub crater in what's now Mexico, it probably did not produce a big spike in carbon dioxide or sulfur dioxide. And this is, again, what the computer analysis found from crunching all the numbers.
Oh, wow. Okay.
All right. So that's the conclusion that these supercomputers made with the data they were given. Does the science community agree? Not necessarily.
Not necessarily.
All right. So now, So let's let the go on.
No, but I understand both sides. Yeah, Lindsay.
Yeah.
Yeah, it makes sense that if there was a lava eruption and, like you're saying, all the gases and everything just contaminated.
And millions of years worth of eruptions as well, right?
Exactly.
A massive, it's not one volcano, it's about a huge.
It would have, the sad reality was, it did wipe out the whole dinosaurs, and it would have wiped
It's entirely possible, right?
almost.
Yeah.
Mm.
However, not all scientists agree with the modeling from the computer. All right. And this is where scientific debate goes on. In fact, I think the conclusion would still be that it was the asteroid. However, it is interesting because it generates important debate. Here's the kind of the rebuttal of all that. But many scientists are not convinced that these findings provide the ultimate answer to this long-standing complex question.
No, I don't think it would be. It's an ultimate answer. I agree with that. Yeah.
So Sierra Peterson, who's a geochemist at the University of Michigan in Ann Arbor, said it's an elegant way to address the problem. It gives freedom to find consensus solution. It takes multiple proxy records into account. But says, however, like any model, output depends on input.
Input.
All right,
That's
so
correct. Yes, correct.
yeah, so the scientists were able to they were able to wipe out bias, human bias, which is really good. But the computers can only work with the information that they're given.
That makes sense. Yeah. Yep.
So the question that the scientists have is, was the input enough for an accurate conclusion to be made? Peterson notes that foraminifera shells are not an ideal proxy for ancient temperatures, as the oxygen isotope ratios in these shells can change not only due to temperature, but also due to seawater composition. Different temperature proxies would likely lead to different patterns of gas release reproduced in models. So now seawater affecting the composition and temperature of the seashells could also account for these isotope ratios in the shells. And this could change the computer or influence the computer's processing and outcome. She adds, the mass extinction culprit then, she says, it's a bit of a leap to say that this study shows the impact, that the asteroid impact didn't cause the extinction. I think what it shows is that the impact was likely not associated with large gas release, but the asteroid, she says, could still have had other deadly impacts on the planet's environment. So the computers, she says, are probably accurate in saying that gases weren't released by the asteroid impacts. Yes, that was the volcano. But she says, what about the other effects of a deadly impact of an asteroid? So she's paleoclimatologist from the University of Connecticut who says that the Chicxulub impact led to many devastating effects beyond carbon dioxide and sulfur dioxide emissions, which are explored in the study. So those massive clouds, for example, of soot and dust that were kicked up from the pulverized rocks due to the impact is another thing. Yep. Research has suggested in the past that this dust may have dimmed the amount of sunlight reaching the Earth by as much as 20%, which most likely induced a frigid winter, which changes the habitats that animals rely on, and swiftly killed off the habitats and plants, which then had this knock-on effect to dinosaurs and other non-bird species as well. So what's more, the new study suggests that the asteroid impact didn't have a long-term effect on the planet's carbon cycle, based on carbon isotope data recorded in the foraminifera shells for the million years after the extinction. There was an abrupt drop in the abundance of those creatures corresponding to the time of the impact, Tabor says, and says this: the rapid rate of change caused by the Chicxulub impact was likely responsible for its effects on life.
Okay.
Yep. So to conclude, it says many geochemical records spanning the extinction event, as well as this modeling work, cannot capture well the rates of change associated with the Chicxulub impact. And this is Tabor speaking as well. The impact, he says, may have released significantly less carbon dioxide and sulfur dioxide than the Deccan traps, but it did so almost instantaneously. So even if the asteroid impact released fewer gases overall, Tabor says the speediness of that release could have been devastating all the same.
Yeah.
Does the modeling help us reach a definitive conclusion that volcanic gases killed all the dinosaurs? No, it doesn't.
No.
But it does. It does release this interesting conversation over the effect of the gases, the effect of the asteroid impact, and the ongoing impacts. Sorry about the pun, of the asteroid in Chicxulub as well. There's some interesting things to think about. And if any American listeners made their way to Mexico and has seen the impact crater, we'd love to hear what your thoughts on this are as well.
I have to go back and have a look at Google and have a look at this. But yeah, it looks whoa, wow.
Yeah. If anyone has any thoughts on what killed the dinosaurs, we would love to know. And you are not allowed to say it was aliens. It was not aliens.
Definitely not.
Yeah, definitely not.
Definitely not.
Unless there was unless there was like a learner driver alien who made a mistake, took a wrong left at a traffic light and hit an asteroid and knocked it in Earth's direction. All right. I'll give you that. But
no, definitely.
But you're going to have to dig really deep to prove that to her. Yeah.
It was like we still have asteroids still falling onto Earth. But of course, they are much, much smaller. At the start, they are big. And you know what it is? They disintegrate in the atmosphere and just become little tiny things. And
Little shooting stars for us to enjoy in the night sky. Yeah.
Exactly. And then, look, I must admit both sides of the story of the research and everything that's been going on. And I understand people concerned putting the amount of information they can into a computer. It's like saying, you want to make a coffee. The only thing you put in is just the coffee beans. That's it. You know what I mean? So that's coffee for you. Maybe we have to put more research into putting what's going on. But
what's going into it? But now I want coffee. Thanks.
Oh, sorry.
We use computer modeling already, really, but it has a lot of potential. And it can do some pretty amazing things. And I think that scientists probably just need to consider what data they're inputting because, again, what were they trying to do? They were trying to come up with a consensus that erased human bias. And I like that. That's good. Yeah, so that you're not leading towards a conclusion before even starting the experiment, right? So computers won't. Exactly. I don't think computers have bias. I hope, unless they're, maybe they have less bias either way.
That's the only way they can have bias is being programmed from us.
Yeah. That's it.
So anyway,
they have a BIOS, but that's it. Yeah, it doesn't.
Oh my goodness me!
Boom, there you are.
Oh, remember those days? Oh,
Happy science. Yeah, I know. That's right.
I think we still have BIOS.
So,
but anyway,
Let's Science is brought to you by StarQuest Media and is a fortnightly podcast that brings you the scientific wonders of our universe from a distinctly Catholic point of view. For more from Caroline, Lindsay, and friends, listen to the StarQuest show, Catholics of Oz. Find links from today's show at sqpn.com/science and find the Catholics of Oz at sqpn.com/Oz. Be sure to follow the show in Apple Podcasts, Google Play, wherever you can find podcasts, or on the SQPN YouTube channel. The generous donations of our patrons at sqpn.com/give make it possible for us to continue Let's Science and all the shows at StarQuest, which makes our nonprofit mission possible. You can join them by visiting sqpn.com/give. Join us next time for more scientific wonders, and thank you for listening to Let's Science on StarQuest. Here's another show on the StarQuest network you're sure to enjoy, The Secrets of Middle-earth. Find it wherever you can find podcasts or at sqpn.com/Middle-earth.